This is Module 2, Lesson 1, Part 2. We're continuing our discussion on quantitative data, and now we're going to focus on how to display that data. We just finished a discussion of how to create or organize our data using a grouped frequency distribution, but an analysis requires much more than that. Graphs are even more useful for providing a lot of information quickly to a reader or to an audience. You'll often see graphs used in newspapers, the internet, professional journals, magazine articles to show trends and to enable readers to compare facts and figures quickly. And there's really no strict guidelines about which graphs we should use when, but sometimes you can think about the information you want to share, and that could help you to decide which would be the best graph to use. For our discussion on quantitative data, we're going to focus on three different graphs. The first is a stem and leaf plot, second is a histogram, and then third is a box plot. Now, in terms of the stem and leaf and the histogram, you don't necessarily have to know how to create one of those, but you will be asked to interpret the information that's provided by those graphs. So let's look first at at the different distributions that can occur when you're looking at graphs, because graphs give us a way to visually inspect with our eyeballs the distribution of the data set. There are four different distributions that you need to know. The first one is the uniform distribution. Within a uniform distribution, each class or group has approximately the same frequency or the same relative frequency. Visually, when you look at it with your eyes, overall, and you take a step back, it looks somewhat like a rectangle. You could imagine drawing a rectangle and then cutting pieces off and filling in the gaps. A uniform distribution visually looks like a rectangle. The second distribution is skewed to the right. With a skewed to the right distribution, most of the data values are on the low end or the left-hand side of the graph, and then it tapers off as you move to the right. So it seems backwards to us because all of the values are clumped on the left, but the description is skewed to the right. So that kind of helps me remember it, that it's backwards to what I would think. It's sometimes also called positively skewed. The third distribution is symmetric. With a symmetric distribution, most of your data values tend to fall in the middle, and it tapers off on each end, which we call a tail. If you could imagine taking the graph and folding it in half, the left side and the right side would be virtual mirror images of each other. Probably an application or where you may have seen this used is the idea of grading on the curve. An instructor tries to have mostly C's in the middle, and then some B's and D's on either side, and then very few A's or F's. So this is kind of the shape or the distribution that's wanted when you talk about grading on the curve. The symmetric distribution is sometimes also called bell-shaped, because you can imagine kind of drawing a Christmas bell across the graph. The fourth distribution is skewed to the left. With skewed to the left, most of the data values are on the high end of the number line, or in this case, on the left-hand side, on the right-hand side, and then it tapers off on the left. I kind of think about this one like take an airplane taking off. It taxis down the runway, and then it starts to lift off, and then reaches its high point until it gets ready to land. Skewed to the left is also called negatively skewed. You're going to be asked to identify the distribution of your data set from a graph using your eyeballs. Let's look at how to create a stem and leaf plot. Stem and leaf plot actually accomplishes two things at once. It not only helps you to get your data organized, but it also creates a picture or a graph. So it kind of puts those two things together. It's a good choice to use if you have a small data set. You wouldn't necessarily want to do a stem and leaf plot if you have, hundreds or thousands of data values. The way we create a stem and leaf plot is we divide each of the data values into what we call a stem and a leaf. The leaf is always the final significant digit or the last digit of the data value. So, for example, if you have a two-digit number such as 49, 9 is the last digit and it would be considered the leaf. In a decimal number such as 2.5, 5 is the last digit of the data value, and so 5 would be considered the leaf. One of the advantages of using a stem and leaf as opposed to a grouped frequency distribution to organize your data is that you're able to retain the raw data. If we have a stem and leaf plot, we could recreate the original data list if we needed to, which we were not able to do if we used a grouped frequency distribution. The stem and leaf plot actually gives us information about the distribution or the shape of the data set. We can get an idea about where the center lies, as well as the spread or the variation of the data. So let's look at our example again about what is the average age in years of students taking classes on the GHC Cartersville campus in spring 2018. It's the same data set we had before, and we're going to set up a stem and leaf plot. Again, if you'll notice, we have two-digit numbers, so the last digit will become the leaf. In this case, that's going to be the ones digit, and the tens digit will become our leaves. We know we have a minimum of 17 and a maximum of 54. So our stems are going to be the tens digits, and the stems are written vertically in a column. So we would have tens, 20s, 30s, 40s, and 50s, or simply 1, 2, 3, 4, 5. For the leaves, in this case, we said it would be the ones digit. The leaves are listed horizontally in numeric order next to the appropriate stem, and they're listed in order, and if they occur multiple times, you list them multiple times. So I can see here that there were 3 students who were 20. There was 1 student who was 54. We can see there was 1 student who was 17. So again, we can kind of see where those values are. So this is a stem and leaf plot of the data set that we're using about the average age of students on the GHC Cartersville campus in spring 2018. Again, we can learn a few things about the data set from that stem and leaf plot, but we still can't really answer the question of what is the average age. We can see that the minimum age is 17, the maximum is 54, the majority of students are under 30. If you go back and look, you'll see that most of the data are within the first 2 rows. And so we can say that the majority of them are under 30. We would expect the average age to be between 17 and 28. Again, that's because that's where most of the data lie. The spread or the range goes from 17 to 54. The center or the middle of the data set is 19. You may say, well, how'd you get that? Well, I know there are 50 values, so if I find the 25th value in the data set, that would be the middle, and that happens to be 19. I can also see, again, if I go back and look, I can see that most of the data is on the low end. When most of the data is on the low end and then it tapers off, that's going to be skewed to the right. Now let's think about a histogram. A histogram is very similar to a bar graph with one exception. For a histogram, the vertical bars are contiguous, meaning there's no gaps between the bars. It's created using the grouped frequency distribution that we talked about in Lesson 1, Part 1. The histogram is going to have both a horizontal axis and a vertical axis. So we're dealing with two different measurements. On the horizontal axis, we would have the group values, and there's different ways to label that. It kind of depends upon which technology you're using, whether it's a calculator, a free website, Microsoft Excel, whatever. The two most common values used are either the midpoint of the group or the class boundaries. And then the vertical axis represents the frequency or possibly the relative frequency of each group. The height of the vertical bar represents, again, the frequency or the relative frequency. But the neat thing is, regardless of whether you use frequency or relative frequency, the graph is going to have the same shape regardless. And the histogram, very similar to the stem and leaf, gives us insight, again, into the distribution, the center, and the spread. I used a computer software program to generate the histogram that you see here. Again, notice that on this visual of the histogram, how the bars are connected together. There's no gaps. There does appear to be a gap around 40, but remember, we didn't have ages between, 35 and 39. So that's probably that particular, shows that particular gap there. So you're going to be given generated histograms, but asked to determine the distribution. So again, if I look at this, again, most of my data are on the lower end, and so we will say that the distribution is skewed to the right. I can see that I have somewhere, my low is somewhere around 16. My high is probably going to be somewhere around maybe 56. Again, I'm using estimations for that. We will discuss box plots a little bit later because we need some additional information before we can talk about box plots. We'll talk about those in Module 2, Lesson 4. And we'll talk a little bit more about graphs and how to verify the distributions as we get into Module 2, Lessons 2, 3, and 4.